Good morning, afternoon, or evening, cats and dogs. Today's video comes from the lesson 8.3 guided notes on area of composite figures. This is going to be a pretty long video since there's a lot of topics here. We're going to start with area of just simple figures like rectangles, squares, parallelograms, triangles, and trapezoids. Then we're going to combine those figures together, plus we'll also see some area of the shaded region questions. So bear with me as we get through this video. Obviously, this is a lesson that would take us several days to complete in class. It wouldn't just be a one-day video. So follow along as best as you can with whatever parts you need. Also be aware this is the first lesson that has some of my materials and some of my answers from last year when everything shut down due to the pandemic. So some of the things might look a little bit different, but bear with me and we'll get through this. So the whole first page of your guided notes includes formulas that are also on your formula sheet. I want to go through them really quickly and just refresh your memory on a few of them or stress a few things that you might not remember or be familiar with. So the first figure we have is a rectangle. We've already talked about how to find the area of a rectangle. That's length times width. In the past, you might have done base times height, but it's really the same formula. For a square, you can do length times width since a square is a rectangle, or you can do s to the second power. S is the length of any side of the square. Parallelograms, this one is new for you. A rectangle is a parallelogram that has all four angles being right angles, but a parallelogram that doesn't have all four angles being a right angle, the formula we use is base times height. The height goes from, it's basically the distance between opposite parallel sides in this parallelogram. So you can see a picture here that'll kind of help you as you go to do your basic probability, or not probability questions, basic area questions. Goodness, parallelogram, area, not probability. All right, triangle. So for a triangle, I'm sure you've seen this before. I have half times base times height. Please know, and this is going to be really important, that the base and height will always intersect or touch each other at a right angle. That's going to be really important for us because really any of the sides of the triangle could be a base, but in this case, the base is the bottom of this thing. It doesn't have to be the bottom, but it is because the height is intersecting it at a 90-degree angle. So you're looking for that right angle to see which sides or which lengths are going to be your base and height. Same thing applies for the parallelogram as well. Back in elementary school, you might have done base times height divided by 2. That works as well. If you're struggling to find your fraction key, you can always replace the 1/2 with 0.5 as well, or also. The last one is the hardest formula. It's the trapezoid formula. Keep in mind that a trapezoid has one pair of parallel sides. There is a little bit of a summary here at the bottom. It talks about the bases of a trapezoid, and we'll mention that here momentarily. But a trapezoid has one pair of parallel sides. Parallelogram has two pairs of parallel sides. The formula that's on your formula sheet is half times h representing the height, and b sub, like submarine, S-U-B, or sub sandwich, b sub 1 plus b sub 2. Those are not exponents. That's really important to point out to you, and I know it says that at the bottom of the page as well. But b sub 1 and b sub 2 are the lengths of the parallel sides. I'm going to highlight that because that's something that's really important for us. And again, the height is going to intersect your b sub 1 and b sub 2 at a 90-degree angle. Again, very, very important for us. You can see a picture here to help you as you're using or working with the formula. So again, down at the bottom, these two things that I'm going to put green dots next to, I've already stressed, but I think they're really important for us. The base and height of any figure will always touch each other or intersect at a right angle. And for the bases of a trapezoid, in case you don't remember, a trapezoid is a four-sided shape that has one pair of sides parallel to each other. Those sides are called the upper base, b sub 1, and the lower base, b sub 2. It's just a way to number your two bases. It's not multiplication, it's not exponents, or anything like that. All right, let's start with our first 9 questions, which are basic finding area questions. So in number 1, we want to find the area of this figure. It is a triangle. So we want to use the triangle formula, and I always start by writing my formula, half times base times height. There's going to be extra numbers here, by the way, that you do not need. So my base and height intersect at a 90-degree angle, which I can see right here. So that means my base is 3 and my height is 2, and it means I do not need the 2.5. So I'm just going to cross it off here. It's not the base or height of the triangle. So I'm going to do half times 3 times 2. I used parentheses for multiplication. I'm going to go through the calculations really quickly so this doesn't get too long, but you can certainly use a calculator to plug these in. It's basically going to be half times 6, since 3 times 2 is 6. It gets us an area, and remember, area labels are meters squared, feet squared, miles squared. In this case, it's centimeters squared. So the area of this triangle is 3 centimeters squared, which means I could fit 3 square centimeters inside of this triangle. Number 2, this is a parallelogram. Identify the shape first, choose the formula you need, which is base times height. Remember, the base and height intersect in a 90-degree angle, which I see right here. So that makes my height 2.5. That's pretty obvious. The base is 3, because even though it's on the top here, the bottom would also be 3 meters. It means I do not need this 4.2. So it's not a bad idea to cross it out if you don't need it. So I'm going to do 3 times 2.5, and again, I'm going through those calculations quickly. And I apologize, it's a little blurry. Again, this is from some of my old stuff that I created. I didn't want to reinvent the wheel and retype all of this. So whatever I used last year, copying from multiple places, made it a little blurry, so my apologies on that. But we get an area of 7.5 meters squared. All right, number 3, we've got a trapezoid here. So we're going to use the trapezoid formula. Half times the height, which again, the height intersects in a 90-degree angle. That's right here. I'll highlight it in yellow. Then we've got, b sub 1 plus b sub 2. Those are the parallel sides. So my height is 7.5. My parallel sides are 19 and 7, which means I do not need the 10, and I do not need the 8. So I'm going to cross them off so I don't use them or aren't tempted to use them, or I'm not tempted to use it. So I've got half times the height, which is 7.5. In parentheses, I have 19 plus 7, not 19 times 7, so be careful there. I do like to not plug all of this in as one step, but I do 19 plus 7 to get 26. So I've got half times 7.5 times 26. I did 7.5 times 26 to get 195, and half of 195 gets us an area of 97.5 feet squared. All right, let's go ahead and move down to our next 3, all of which are trapezoids, by the way, because that's the hardest formula. I figured I'd throw as many of these in as possible. Feel free, if you want to try number 4 on your own, to pause the video, try it, and then restart the video when you're ready. All right, like I said, this is a trapezoid, so we're going to use this formula. And again, that's really blurry, so my apologies. Remember, the base and height are going to intersect at a 90-degree angle, so that's going to be this right here. My height is 17, and my bases are 7 and 26. They're the parallel sides. I'm going to stress that many times. I'm going to cross off my non-parallel sides because I do not need those. I'm going to replace h with 17. I'm going to replace b sub 1 and b sub 2 with 26 and 7. 26 plus 7 is 33, so I have half times 17 times 33. 17 times 33 is 561, and half times 561 gets us 280.5 millimeters squared. Again, just working through it step by step. Write the formula, substitute the values that you know, eliminating any you don't need, and then just plug and chug from there. If you're struggling with plugging it into your calculator, you're not getting the same solution, please double check. It could just be a simple mistake. Certainly check in with me as well, and I can help you. All right, so number 5, this kind of looks like a crystal or something like that, or a gem, the way it's situated. So it looks a little bit different, but it is a trapezoid since we have one pair of parallel sides. That's going to be these guys right here, like the left and the right. We're going to use the formula half times the height, and then in parentheses b sub 1 plus b sub 2. My height, remember they intersect at a 90-degree angle, which I have here, so my height is 2.5. It doesn't go top to bottom this time, at least not in terms of like top of the screen to bottom of the screen. My parallel sides will be my bases, so that's going to be 7 and 13, which means I can eliminate the 5 and the 3. I don't need those at all. So let's replace what I know. We're going to have half times 2.5, and then in parentheses 13 plus 7, which is going to be half times 2.5 times 20. 2.5 times 20 gets us 50. And half of 50 is an area of 25 inches squared. The last one I threw in a few years ago, just because students really struggled with this. They assumed that the bases were 6.5 and 6, and then struggled to figure out what the height was. because they saw a 90-degree angle. But if you remember that the formula B sub 1 and B sub 2 represent the parallel sides, I'm going to highlight those here. The parallel sides are going to be this side right here and this side right here. So I'm definitely going to be using the 8.5 and the 7.5. And sorry if you heard some cackling in the background. My son turned 6 yesterday and got a Nintendo Switch, so my husband and son are both playing that out in the living room, so you might be able to hear them. We've got our 90-degree angle right here, and then we've got our height of this thing to be 6. That's the distance between your two parallel sides. So when we say the height, we can also refer to it as the distance between the parallel sides. This time we only have one number we're not going to use, which happens to be that 6.5. So sometimes students mix up which numbers go where. The 8.5 and 7.5 are going to be B sub 1 and B sub 2, but they can be mixed up. But you can't mix up the height. The height has to be 6 here. So we're going to do half times 6, and then in parentheses 8.5 plus 7.5. That gets us half times 6 times 16. 6 times 16 is 96, and half of 96 will be 48 meters squared. All right, so let's keep rolling through these here. We're going to take a look at number 7. This one is a parallelogram, so make sure we use the right formula. Base times height. Again, base and height intersect at a 90-degree angle. My height is the distance between my parallel sides here, which is going to be 9, and then my base is going to be 4.5. So I do not need to use the 10. Get rid of it. All we have to do is take 9 times 4.5 in any order, and that is going to get us 40.5 yards squared. Now, underneath that, there's a question I want to take a look at before we move on to numbers 8 and 9. So it says, Giles's backyard is shaped like the parallelogram above. Really weird shaped backyard, I guess. He would like to put new sod, which is grass, in his yard. If it costs $12.50 per square yard, how much will it cost to sod his yard? Well, let's keep in mind that this yard is 40.5 square yards big, and we know it's $12.50 per square yard. So what do you think we're going to do to find our solution here? If you're thinking, well, we have to multiply the 40.5 times 12.50, you're correct. So take 40.5 times 12.50, you will get $506.25, 506.25. So pretty expensive, although putting new grass in your yard is pretty pricey. So a little bit of an application problem there. We'll continue to see those in a little bit. We're going to see a fertilizer question in a few moments. Keeping on that track of grass problems, right? All right, number 8, we've got a triangle. So the formula we're going to use is half times base times height. Our base and height intersect at a 90-degree angle, which I see here. My height is 3. My base is 13. It means I do not need to use the 5.5. So I'm going to do half times 13 times 3. That's going to get us half times 39, and half of 39 is a decimal, 19.5 meters squared. Don't forget those labels, even in your notes. They are going to be really important for us. And the last one from this page, we've got a parallelogram. The formula is base times height. The base and height intersect at a 90-degree angle, which we have here. My height is 1.5. My base is 3.5. I do not need to use the 3. So we are going to do 3.5 times 1.5, and our total area will be 5.25 centimeters squared. All right, so let's kick it up a notch. Let's go ahead and take a look at some application questions, some questions that involve scale mixed in with area problems, and then we'll go from there. Again, this video is pretty long, but you shouldn't have to watch the entire video all at once because this is a lesson that's going to take us several days to do. So just pick the questions you need to see and watch those questions and follow along with that. So number 10, Brian's yard has the dimensions shown below. Makes a little bit more sense, a rectangular yard. First thing we need to do is find the area of the yard. Well, it's a rectangle, so we do length times width. That means we do 90 times 50. You can use the dot for multiplication as well. I use parentheses here. It's going to get us 4,500 feet squared, or 4,500 square feet. Part B, Brian is going to fertilize his yard. One bag of fertilizer covers 3,000 square feet. How many bags of fertilizer will he need to purchase for his yard? So first of all, it's a 4,500 square foot yard. We're going to need more than one bag here. So one way to do this is to take 4,500, the total area, divided by the amount needed or amount covered by each bag, which is 3,000. 4,500 divided by 3,000 is going to get us 1.5 bags, but you can't just buy half of a bag, so that means you're going to have to buy 2 bags. And you might realize that without having to show this division step, and that's fine. Again, 2 bags is going to cover 6,000 square feet, which is going to give you enough with a little extra left over. All right, so number 11, we're still in the same set of guided notes. It asks us to find the area in square kilometers for this figure, but all the dimensions are given to us in meters. And there's a review box on there as well that you don't have on the screen, but it's in your notes. And it says, with scale drawings or scale models, the scale is the ratio of the measurements in the drawing or model to the measurements of the actual real-life object. So if a map scale is 2 centimeters equals 5 miles, means that every 2 centimeters on the map represents 5 miles in real life. In our example number 11, we've got 1 meter equals 5 kilometers, which I'm going to go ahead and highlight here in yellow. It means that 1 meter on this drawing or model that we have represents 5 kilometers in real life. So I suggest converting each of the dimensions first. Now this is a trapezoid, so we're using the formula half times the height and then b sub 1 plus b sub 2. So I want to look and see. It looks like I did convert them all. Okay. So I'm going to just pull this off and then I'll explain how I got these. So I converted all the dimensions, not the ones, even the ones I didn't need. So you wouldn't actually have to convert all of those. We'll talk about that in a moment. But the 1.6 meters, which is this base as well as the height of this thing, is equivalent to 8 kilometers. Now you might be thinking, how in the world did she get that? Well, what I did was I took, since 1 meter is 5 kilometers, I took the 1.6 times 5. So if you take 1.6 times 5, that will get you 8 kilometers. Luckily, when it's 1 meter equals something or 1 unit equals something, you can just multiply your dimension by whatever that scale value is. So for the 1.8 meters, that's this side that I'm not going to need here in a moment. If you take 1.8 times 5, that's going to get you 9 kilometers. If you take 4 times 5 for this bottom base here, that'll get you 20 kilometers. And for this side, I took 2 times 5 to get 10 kilometers. Again, it may not be a bad idea to write down how you get those. Again, you get them by multiplying by 5. Had I done this year, I probably would have typed that in. Last year when I created this stuff, I didn't have that work typed in, but we're going to multiply each of those dimensions by 5 to get your kilometer value. So it's not a bad idea to now recognize which numbers we need. We've got our right angle here, so we're going to need this value here, our parallel sides here for our bases, and we can eliminate these. So you probably, when you converted your dimensions, could have ignored the 1.8 and the 2 and just done these two. Right next to these, I'm going to type in what they are. So the 1.6 meters is 8 kilometers. So I'm going to type that right next to it so we have it. And then I know the height is also 8 kilometers, so I'm going to slide that over here. And then our 4 meters is going to be 20 kilometers, so I'll put that right here. So let's plug these into our formula. So we're going to have half times 8, since that's the height. Whoa, sorry about that. Half times 8, since our height is 8. And then in parentheses, 20 plus 8. So that's half times 8 times 28. 8 times 28 is 224, and half of 224 is 112 kilometers squared. Now, I want to point out that should you choose, and we did this a little bit with circles, should you leave them as meters and convert, you cannot just multiply by 5 at the end. You would have to convert 1 square meter into 25 square kilometers. So you'd have to take your answer in terms of square meters and multiply by 25, not 5. I don't suggest doing it that way. I suggest converting them first, plug them in your formula, and go from there. But again, you could eliminate any sides that you don't need to use. This is probably a little bit harder than what you're going to see on the test for the most part. But this is something we'll continue to review throughout this unit and throughout this lesson as well. All right. Now, the next thing we're going to talk about is composite figures. And in your notes, it says these are shapes that are made up of more than one simple shape. And in fact, a lot of real life shapes are composed of more than one simple shape. To find the area of composite figures, we're going to split or break apart the shape into figures that we do know and we're able to find the dimensions of, find the area of each shape, and then add the areas together. There are going to be times where you may need to find a missing side length that is not given. Make sure you're not just guessing what the side lengths are. You should definitely be using math to figure out what the side lengths are. Don't say, well, I think that looks like it's 6 inches because that one's 12 inches and this looks to be about half. That's pretty hard to eyeball it without knowing for sure what that value is. So use math to figure those out. So I've got some examples of patios that are made up of maybe some semicircles or maybe a quarter of a circle, made up of more than one rectangle. A lot of rooms are made up of more than one shape as well, where we have even our classroom where we have the cutout for the doorway, poles. Again, a lot of things used in real life are going to be composite figures. They're not going to be perfect rectangles or squares or trapezoids or parallelograms. All right, so I know I already mentioned this. We're going to go right into our example. So I'm going to go ahead and turn the page. You're going to notice for these examples, I didn't put boxes over everything to hide it. So listen as we're talking through this. Don't just start copying and zone out. I want to go through this step by step. So number 12, we've got our, I'm going to call it an ice cream cone. So it looks like a sideways ice cream cone, and it's already split up for us with this dotted line that I'm going to highlight. So it's composed of two shapes. The semicircle I'm going to call like shape one. Whoops, sorry about that. I'm going to call that shape 1. Sorry, it like froze up for me there for a second. So that's going to be shape 1. And then our triangle is going to be shape 2. You don't have to put the numbers in there, but I do think that sometimes helps. So this is region 1 right here. This is region 2, just showing you the two different parts it's composed of. So we're going to start with the semicircle here. And remember the formula for the area of a semicircle is half pi r squared. I'm going to highlight that in green. I always like to start by writing the formula. Now I did copy over values that I knew, so I did label this to be 9 yards right here. It's shown up here, but that's the same as the length of this dotted line. That represents, by the way, the diameter of this semicircle since it goes the whole way across. The radius is half of that. We need to find that for this. The radius is 4.5. So we do half times pi times 4.5 squared. 4.5 squared is 20.25. So you do half times pi times 20.25. And I'm going to stress that it would not be a bad idea for you to pause the video and try plugging these into your calculators yourselves. Half times pi times 20.25. I did half times 20.25 to get 10.125 pi to write an exact answer in terms of pi. That's approximately 31.8 yards squared. Again, that's for the semicircle. The one thing that students often forget is they forget to divide by 2 or multiply by a half since it's only a half circle, not a full circle. So be careful with that. You're going to notice when I go to find my total area down below, I used the decimal. You could also do 10.125 pi in replacement of this 31.8. It doesn't matter. You should get the same solution either way. Now my triangle is region 2, and I'm going to outline that here in purple. So that's this region. And I did copy some values over. So the base of this triangle is going to be the 9 yards. You do need to write that in. So it's going to be this here. It's the same length of this dotted line. You sometimes have to reuse values. And then this that I'm going to highlight in green, the 13 yards, that represents the height of the triangle. So I know there's not actually a right angle here, but that would represent the height of this triangle. Sometimes students want to split this into 2 triangles. Don't do that. This is just one big triangle where the base is 9, height is 13. So you do half times 9 times 13 is half times 117. 9 times 13 is 117. That gets us a total area for region 2, which is our triangle, to be 58.5 yards squared. So if we add 58.5 to the 31.8 to get our total area, that's going to get us about 90.3 square yards or yards squared. So again, find the area of each region, add them together to get the total area. Taking a look at number 13, I split this up in one way. Please know that there's another way to split these things apart, and we'll talk about this as well. But I split this apart by drawing dotted lines across here horizontally and across here to break this into 3 rectangles. So I'm going to call this right here region 1. And that's going to be this guy down here. So this is already, some of this is already in your notes, but there's some things to copy in. So this is region 1. And when I outline this, I'm going to outline it here in yellow. So I've got a length of 8 and a height or width of 3. So my dimensions are 8 by 3. You don't need the 10 here. You don't need the 4. That will help us find the length of this dotted line here, but it's 8 across, 3 high. So to find my area here, I'm going to do 8 times 3 to get 24 miles squared. Again, that's for this yellow highlighted region here, 8 times 3. Let's go ahead down. I'm going to call this region 3, but I'm going to do this one next. This skinny rectangle here, slightly smaller. I'm going to outline it in green. So we want this whole distance across and this high. So we can kind of see that the length of this thing is 6, the height is 2. So I'm going to slide this down. So this is going to be our region 3 right here. It's 6 by 2. So to find the area, I'm going to do 6 times 2 to get a total area of 12 miles squared. Again, that's for this rectangle here. Again, we're going to be adding the 24 and the 12 together plus our final answer. So that's going to be for region 2. These are tough. This is going to require a couple of days of practice, and that's okay. So this is region 2 here that I'm going to highlight in blue. Grab my highlighter here. So it's going to be across here, down here, and so forth. The problem with this is that there's no actual dimensions written right here. I know that this entire length across here is 8. I know this part is 4, which tells me that this dotted line right here also has to be 4, since 4 plus 4 is 8. So I know that this region right here, that length, that dotted line, I'm going to make that kind of small there, this should be 4 across here. So you can see I wrote that down here, which I'll slide down in a moment. Now I know this entire distance right here is 10. I know this part right here is 3. I know that this part down here is 2. So I have 3 plus 2 for this part, which means this middle part, the blue highlighted part, has to be 5. So I know that the dimensions of region 2 are 5 by 4. So you can see this in the picture down below. Here's region 2. It's 5 by 4. So I'm going to take 5 times 4 or 4 times 5, and I'm going to get an area of 20 miles squared. Again, that's for that blue region. This is where, again, I don't want you to just guess and say, well, I think this looks to be 4, or I think this looks to be 5. Use math to guarantee that those values are, in fact, true. To find our total area, we'll add the 24 to the 20 to the 12. You can see I did that down here. The final area is going to be 56 miles squared. Now, is there another way to break up this figure? Absolutely. You could draw those lines vertically instead of horizontally. So I could have actually split it up by drawing lines along here. So you'd have a really long skinny rectangle here and then some smaller rectangles or squares over on the side. You should get the same answer. That being said, it's going to look, your work's going to look a little bit different, but the same final solution you should get no matter how you divide this thing or split up this shape. So let's take a look at number 14. Now you can see I did draw a line in here to split this thing up. So I drew a line across here, and we're going to divide this into a semicircle and then 2 triangles. They're both going to be the same size, and since they're the same size, we can find the area of 1 triangle and then double it since we have 2 triangles of the same size. But let's start with the semicircle or half circle first. That's going to be region 1 here. Now I did not draw a picture. That being said, you certainly could. I'm going to highlight this guy in yellow as best as I can. So this is going to be region 1, and that's what I'm going to be doing right down here. So the diameter is the whole way across. This happens to be 20 going the whole way across here. It's listed down at the bottom. So the diameter is 20, which makes the radius of this thing half of that to be 10. It's a semicircle, so we do half times pi r squared. So you do half times pi times 10 squared. 10 squared is 100. Half times 100 is 50 pi for that semicircle. That's about 157.1 meters squared. We'll just round to the nearest tenth. So that is the semicircle. Now, the triangles, I'm going to consider region 2. I'm going to put a 2 inside each of these. So I'm going to find the area of one rectangle and then one triangle, and then double it. Sorry if I called them rectangles. It happens sometimes. That's going to be these two regions together. I'm just going to highlight one of them though. So the base and height, they're going to intersect at a 90-degree angle, which we would actually have right here. So we'd have a 90-degree angle. Oops, I tried to make a box there, but we'd have a right angle in this corner here. So my base and height are going to be this length across here and this length down here. I know this is 8, and I know this is the same as the radius of the half circle, which is 10. So I'm going to do half times 10 times 8, which is half of 80 or 40. Now, I'm doubling that since I happen to have two triangles that both have the same base and height. They're the same size and shape. So the total area of the triangles will be 80 meters squared. Again, that's for both triangles together. So one triangle is 40, double it to get 80. So my final answer, I add the 80 to the 157.1. The two triangles are 80. The 157.1 is from the semicircle. You're going to get a total area of 237.1 meters squared. All right, question number 15 looks a lot like a track where we have a rectangle in the center. So I'm going to call that region 1. And then we have two semicircles which can form a whole circle since they happen to both be the same size. So you could either do a half circle times 2, or you could put them together to form a full circle. And we'll mention that when we show the work. So let's start with the rectangle that I'm going to highlight in yellow here. The dimensions are 16 by 11. So length times width is 16 times 11. You can see that work right here. That gets us 176 inches squared. Now for my semicircle, I'm going to do just one at a time. We're given the diameter of this thing. That's the distance the whole way across. That's 11. That means the radius is going to be 5.5. That's really important for us to have. That's half of 11. So I do half times pi times r squared for this semicircle. Is half times pi times 5.5 squared. 5.5 squared is 30.25, and half of 30.25 is 15.125 pi. So that's about 47.5, but since I have two semicircles that are the same size, that's why I do times 2 here, and that's going to get us 95 inches squared for the two semicircles. Now you could also do just pi r squared, where r is 5.5, and we're just doing that for a whole circle because the two semicircles together would form a whole circle. So if you do pi times 5.5 squared, that's going to get you the same solution, about 95 inches squared or square inches. So to find my total area, I'm going to do the 95 from the two semicircles, that's this right here, plus the 176, goodness, you can tell this is getting to be a long video, from the rectangle that we had for a total area of 271 square inches. All right, let's take a look at number 16. Now there's going to be some questions for you to try on your own. Some of these you might be doing towards the end of the week when I may be out one of those days, depending on when you're listening to this. So there may be some things you'll still have to watch or listen to. So number 16, we have two triangles that are both the same size and a rectangle. I'm going to start with the rectangle since I think it's a little bit easier. And I will highlight this thing in yellow. So dimensions are 24 across, 8 high. So it's going to be this. So base times height or length times width is 24 times 8. That gets us a total area of 192 yards squared. Then my two triangles, sometimes students want to split it into 4 triangles because of the dotted line going through these. Just treat the entire triangle as one. I'm going to highlight just one of them in green. Again, we'll find the area of 1 and then just double it. So the formula for the area of a triangle is half times base times height. The base is 24, the height is 8. Half times 24 times 8 gets us half of 192. So one triangle is 96, but I'm going to multiply by 2 since I have 2 of them, including this one down here at the bottom. The total area of the 2 triangles together is 192 yards squared. Some students recognize that they could just take the half out of the formula because you're going to double it anyway, and that works. I'm not going to point it out that way because I don't want students to mix up the formula later on, but if you take the 1/2 out of it and just do base times height, because those 2 triangles together could form a rectangle, you can do that, or a parallelogram. So the area of the 2 triangles is 192, plus the 192 that I got from the rectangle. That's going to get us a total area of 384 yards squared. All right, let's keep on chugging along. So there's some additional practice number 17 through 19. These are ones that I'll actually probably suggest you try on your own a little bit. But let's go through these together here in the video. And you might be listening to this if you've already tried the questions, and that's okay too. So number 17, this looks a lot like our first question, number 12, where it's like the ice cream cone. So I'm going to start with the triangle. Why not do that one first here? So this is going to be region 1 for us. And it's one big triangle. Again, sometimes students want to split it into 2 triangles because the dotted line, that just represents the height of the triangle. So I'm going to treat it as just one big triangle here that I'll highlight in yellow. And it's half times base times height is going to be half times 10 times 15. So you can see that work here. 10 times 15 is 150, and half of 150 is 75 centimeters squared. So that's for region 1. Again, one big triangle with a base of 10 and a height of 15. Region 2 is going to be this semicircle. I'll outline that in green for us. So that's going to be this region here. We have a diameter of 10. The radius is half of that to be 5, so make sure you're using the radius. So since it's a semicircle, I'm going to do half times pi times r squared. You might be wondering, are we ever going to have a whole circle? It's possible, of course. Replace r with 5, so we do half times pi times 5 squared. 5 squared is 25. Half of 25 is 12.5 pi. So I wrote my answer in terms of pi. But to the nearest tenth, that's about 39.3 centimeters squared. And again, all this work here is from our semicircle. Don't forget the 1/2 since it's only a half circle. So add your 75 from your triangle to your 39.3 from your semicircle, and you're going to get a total area of about 114.3 centimeters squared. All right, let's take a look at our next region. We've got a rectangle and a triangle. So this one's not too bad. I will tell you that 19 is, I think, one of the hardest questions. So if you're struggling with that one, don't be surprised. It's a tough one. So let's start with the rectangle. I'm going to outline that here in yellow. So it looks like my height or my width is 5. My length is 10. So we're going to do 10 times 5 to get the area of that region. That is 50 centimeters squared. Our triangle, again, this is just one big triangle up here. So I'm going to call that region 2. Don't split it into more than 1. So we've got a height of 3, and then this entire distance across is going to be the base. We know that happens to be 10. So we do half times 10 times 3. Again, that works down here. 10 times 3 is 30. Half of 30 is 15. So the area of the triangle is 15. So we add our 50, which came from the rectangle, to our 15 that came from the triangle to get a total area of 65 centimeters squared. Now, again, this last one here before we get into, well, there's still another one coming up, but until we get to some other questions, number 19, that one is a really tough one, I think. So in number 19, I did draw a line in here to split part of this up. So that's going to be this line right here. So that made a triangle right here. So we actually have 4 regions, and unfortunately none of them are the same size. So let's start with region 1, which is going to be the rectangle. That's the easiest one. Might as well start with the easiest work. So the base and height of this thing are going to be 6 by 9. So we're going to take 6 times 9 or 9 times 6. That work is right here. That gets us a total area of that region of 54 yards squared. Some students like to write the area in the picture, That works too. I'm not going to do that here to crowd it up too much more, but you certainly can do that. All right, let's do our larger semicircle next. I'm going to call that region 2, which is going to be right down here. I'll highlight that guy in green. So that's going to be this region right here. And the diameter going across is the base of this rectangle here, which is 9. So diameter is 9. The radius is 4.5, half of 9. So that's going to be this work here. Let me go ahead and highlight it, and then we'll work through it together. So it's half pi r squared. Replace r with 4.5. 4.5 squared is 20.25. Half of 20.25 is 10.125 pi, which is about 31.8 yards squared. Again, that's for this region 2, this semicircle. Let's do the smaller semicircle next. So as we go to look through that, I'm going to highlight that in blue. That's going to be region 3. So that's going to be this guy right here. So we'll call this region 3. The diameter of this thing is 6. That's 6. I know it's kind of hard to see what it's pointing to, but since we drew this line in here, the 6 is referring to the diameter of this semicircle. So the diameter is 6, which means the radius is 3. And again, my work is going to be down here, so let me go ahead and outline it, and then we'll go through the work. So since the radius here is going to be 3, we're going to do half pi r squared because it's a semicircle. That's half times pi times 3 squared. 3 squared is 9. Half of 9 is 4.5 pi, which is about 14.1 square yards. Now, our last region here is going to be our triangle. So that's going to be region 4. Let me go ahead and put a 4 in here. And I will highlight this in purple. So it's going to be this region here. Now, the 5 we need to use for this, that's going to represent the height of the triangle. And then the base is where it's going to intersect. So it's going to intersect down here, this line that we drew in, which I know is 6, not because of the 6 here, but because of the 6 over on the other side of our rectangle. So base and height are 5 and 6. So the formula for the area of a triangle is half times base times height. So it's half times 6 times 5, which is half of 30, or 15 yards squared. So we add the 54 from the rectangle to the 15 from the triangle to the 31.8 from the larger semicircle or half circle to the 14.1 from the smaller semicircle, and we finally get a total area of 114.9 yards squared. Now, not unusual. These questions right here, I think, are more challenging than what you're going to see on your test or on a quiz or anything like that, but I still think they're good problems for us to take a look at. That will help you do the easier problems a little bit quicker or in a simpler way. It won't be as difficult or as challenging for you. That being said, the problem we're about to see, you're going to have one just like this on your test, so I definitely want to stress this here. You're also going to have an extra practice sheet that goes along with this stuff. All right, so let's take a look at number 20. Again, I didn't put any boxes or anything like that in here, so just, pay attention as we go through each of these steps. Now, there are other ways to split this up, and if we're doing this in class, we're definitely going to show you multiple ways to split up this region. What I did was I drew a line vertically down here, so I'm going to highlight that line because I drew this line in. And so I broke this down into a rectangle, and then a triangle. I've had students who split it horizontally here and then vertically as well, so they end up with like multiple rectangles and then a triangle. I've even had some students break it apart. I'm going to draw this in and then I'll erase it. Instead of putting the vertical line that we have here, they draw a diagonal line here and make it into 2 trapezoids. That can work as well. And that's something we can certainly take a look at in class. I'm not going to show every possible way to do this in the video, but it's something we can definitely look at in class. So let's start off with our rectangle that's on the left, and that's going to be this one right here. And the dimensions of this, let me go ahead and highlight it in yellow, are going to be 9 by 4. So we've got 9 by 4 here. So I take 9 times 4, or 4 times 9, to get 36 feet squared for the area of region 1. Again, let me outline this in yellow so you see where it comes from. Then region 2 is another rectangle. So for this one, I'm going to outline it in green. So it's 9 across, that's this distance, but we need to find the height of this thing. Often I will have students do 16 across, but that's the whole way across here. And I'm only looking for this green highlighted part here. And I'm also only looking for this green highlighted part. So this is not 9. Now what I do know is this part is 4. And since the whole thing is 9, it means that this length right here where I'm outlining has to be 5. So I'm going to put a little 5 in there just to show you. I'm trying to make it small, but not too small. So yeah, this right here should be 5. 4 plus 5 gets us a total of 9. So I'm going to do 9 times 5, or 5 times 9. Go ahead and outline this for us. Ooh, there we go. That's going to get us a total area of region 2 that's 45 feet squared. Then we finally have our triangle here. I'm going to call that region 3, and I'm going to highlight it in blue. So that's going to be region 3. Now I do not need the 5.8. In part, or question number 21, I will need the 5.8, but the base and height are going to be the dotted line and then this distance right here that's highlighted in blue. Now keep in mind that I know that this yellow highlighted part is 4, green highlighted part is 9. That's a total of 13 going across here, which means that this blue highlighted portion down at the bottom there needs to be 3. That's going to be really small to fit in there. That's going to be 3 going across here. We already said that this distance here was 5. So we do half times 3 times 5. 3 times 5 is 15, and half of 15 is 7.5 feet squared. Again, don't assume because a number is there you have to use it. I do not need that 5.8 at all here. So we're going to add the 36 from the rectangle on the left to the 45 from the rectangle that's in the middle to the 7.5 from the triangle to get a total area of 88.5 feet squared. Now again, are there other ways to do this? Yes. I'm not going to address every single way in this video, but in class we will certainly show you other ways. So if you're watching this video because you're absent or you missed something or you'd like to see if a different way could possibly work, just check in with me during an enrichment period or during class. If I can't address it during class, we can look at it during enrichment. Now, number 21 asks us to find the perimeter of this figure. So I'm going to erase some of my highlights from over here. And perimeter is the distance around the outside. So we have to add up all the outside side lengths. So we have to do 4 plus 4 plus 9 plus 5.8 plus the 16 all the way across the bottom plus the 9. So you see all those numbers there. 4 plus 4 plus 9 plus 5.8 plus 16 plus 9 gives us a total perimeter of 47.8 feet squared. Sometimes I have students who are like, well, let me find the perimeter of this rectangle. 2 times 9 plus 2 times 4. But then you're including parts that are not on the outside. So you're actually including this line that we drew in here that's of length 5. We don't want to include that. So just add up all the sides on the outside, and that will get you your perimeter. All right, let's go ahead and take a look at number 22. We're almost there. We're getting there. In number 22, it says a blueprint of a playground for a local community consists of a rectangle and 2 semicircles as shown in the diagram below. The scale is 1 inch equals 12.5 yards. So a couple of things. Remember that even though 1 inch equals 12.5 yards, according to the scale, that does not mean that 1 square inch equals 12.5 square yards. Therefore, it is easiest to first convert each measurement to yards before finding the area, since we want the area in square yards, as you'll see this here in a moment, because we're finding the area, the actual playground. Also note that since the scale started with 1 inch equals 12.5 yards, we can convert each measurement to yards by simply multiplying by 12.5. I know we mentioned that before. But if the scale did not start with one option we have would be to do the conversions using a proportion each time. The fortunate thing is we don't need to do that here. So we've seen this shape already, just not with scale. So first things first, let's go ahead and sorry about that beeping. My son must have gone into his room and so the monitor was starting to make noise over there. So I'm going to convert the 1.2 inches into yards. Take 1.2 times 12.5 from the scale that's given. It's highlighted on your paper too, just not yellow on your paper, it's gray. That's going to be 15 yards. So I'm going to put next to this 15 yards in parentheses. Make that a little bit smaller. So this is going to represent 15 yards. 2 times 12.5 is going to get us 25 yards. That's going to be this length right here. Okay. So if we want to find the actual area is going to be in square yards, not square inches, because that would be a really tiny playground. We're going to use our yards values. So we're going to start with the rectangle, which I'm going to highlight in yellow, and I'm going to have to go back and forth here. So our dimensions are 15 by 25. So for the area, we're going to do length times width, 15 times 25. You can see I did this year. It's not as blurry, right? 15 times 25 is going to get us an area of 375 yards squared. So for this part then, for the two semicircles, instead of doing a semicircle and then doubling it, was I just said, well, the two semicircles are going to form one whole circle together. So I'll highlight those in green. The diameter of each semicircle, or the diameter of the whole circle, is going to be the 15 yards, this distance right here that I'm highlighting. So if the diameter is 15, the radius is 7.5 yards. So I just did pi r squared. Now keep in mind you could do half pi r squared and then double it at the end. But I did pi r squared, so I did pi times 7.5 squared. 7.5 squared is 56.25. So for the area of the whole circle, the two semicircles combined, we get 56.25 pi, which is about 176.7 yards squared. And again, this is for the two semicircles combined. So to find the total area, we do the rectangle, which is 375. I actually put 56.25 pi here, but you can replace that with the 176.7. We get about 551.7 yards squared for the total area. So again, just mixing scale in a little bit with finding area of composite shapes. Let's take a look at another one of these. All right, number 23. It says Hassan has designed a scale drawing of a brick walkway as seen below. The scale of the drawing is 0.5 inches equals 4 feet. Now, to make things easy on myself, I converted that to 1 inch equals 8 feet. Since a half inch represents 4 feet, it makes sense that 1 inch would represent 8 feet. So I multiplied each of these dimensions by 8. So 0.5 times 8 gave me 4 feet. So you may want to copy those down. 0.75 times 8 gave me 6 feet. 0.5 inches times 8 gave me 4 feet again. And 1.5 inches times 8 gave me 12 feet here. And I also split it into two regions by drawing a line right here to make it a rectangle and a trapezoid. So let's start with the rectangle. I'm going to highlight this in green since I already used yellow. So the rectangle, we can see the dimensions of this are 4 feet by 6 feet. So we're finding the area of the actual walkway, which is in feet, not inches. Otherwise, we'd have a really tiny walkway. So we do 4 times 6 to get 24 feet squared. So this is for our, whoops, sorry about that. This is for our rectangle. And now we have our trapezoid. So that formula is half times height, b sub 1 plus b sub 2. I'm going to highlight that in blue. That's going to be this right here. The height of the trapezoid is the 0.5 inches, which is 4 feet. And b sub 1 and b sub 2 are going to be the parallel sides, so that's 4 and 12. So we do half times 4, and then in parentheses, 4 plus 12. 4 plus 12, of course, gets us 16. So we do half times 4 times 16. 4 times 16 is 64, and half of 64 is 32 feet squared. So if I want the area of the entire walkway, I'll add the rectangle, which was 24, to the trapezoid, which was 32, and I get a total area of 56 feet squared. Now part B is application. One case of bricks costs $25 and covers 6 square feet. How many cases are needed to cover the walkway with bricks? What would be the cost? So here's the thing. I've got an area of 56 square feet, and every case covers 6 square feet. So I took 56 divided by 6, and I got 9.3 repeating. But I can't buy 0.3 repeating cases or bags or anything like that. So I'm going to need 10 cases, and it's always good to have some extras in case some of them get broken or if you need to replace one as time goes on. So we need 10 cases. They're $25 a piece. 10 times 25 gets me $250. All right, let's finish up this video. It's getting really long by talking about area of the shaded region. And again, I didn't cover anything up, so don't just start copying and not listen to the explanation. Listen to the explanation and copy as we go along, pausing as needed. So we're trying to find the area of the region that's shaded here. So what I'm talking about is this shaded region around this square that we have. Here's the problem with this, is these are not really semicircles. If you put two of these together, it would form sort of an oval figure, not a semicircle. So sometimes students think, well, I'll just find the area of like two whole circles. That's not going to work. What we can do, though, is take the area of the entire region, which is the circle, and subtract off the area of the square. Like imagine cutting out the square, it would leave you with these shaded regions here. So if you have a circle, you cut out the square, you're going to be left with the shaded region. So you have to find the area of each region and subtract them. So let's start off with the area of the entire circle. The radius of this thing is, I'm going to highlight it in blue, is 8 inches. It goes from the center of the circle to the outer edge. So pi r squared is pi times 8 squared, which is 64 pi, or about 201.1. Now I did use 64 pi up here. So the area of the circle, that's all of this stuff right here. And I wrote it right up here. So area of the circle is 64 pi. Now for the square, I'm going to go ahead and just highlight that in purple. That's this region that we're going to take off. Not very good highlighting there. But every side has length 11.3. So we do 11.3 to the second power, or 11.3 times 11.3. The area of the square is going to be 127.69 inches squared. So if we take the area of the whole picture, the whole circle, which includes the square as part of it, we have 64 pi, or about 201.1, minus 127.69. It's going to give us the area of the shaded regions, which is about 73.4 inches squared. All right, so number 25, to find the area of the shaded region, take the area of the entire figure. The entire figure is a trapezoid. Subtract off the area of the triangle. What that will do is give you these two shaded regions. Imagine you cut this triangle out, you're going to be left with the shaded regions. So let's do the area of the trapezoid first. It's half times the height. The height of this trapezoid is the 11 feet, the distance between your two parallel sides, times b sub 1 and b sub 2, which are 6 and 13. So half times 11, and then in parentheses 6 plus 13, which is 19. 11 times 19 times a half is 104.5. So you can see we have that here. The area of the triangle is half times base times height. The base and height of this triangle are 11 and 6. So half times 6 times 11 gets us 33 feet squared. If we take 104.5 minus 33, we get 71.5 feet squared. All right, let's look at our last problem, which is question number 26. So there's two ways to do this. I'm going to show you method 1, which is the more traditional way, and then we'll show you method 2. So the shaded region is right here, and I'm going to take the area of the entire shape, so the larger triangle, which I'm going to outline in yellow. So we'll find the area of the larger triangle. Base and height are 12 and 16. So we do half times 12 times 16. That's down here. That's going to get us 96 meters squared. So that's for the bigger triangle. Now we want to cut out this smaller triangle, which I'm going to outline in green. And what that will do is leave me with the shaded region. The base and height of this are 10 and 7.5. So down here, I'm going to do half times 10 times 7.5, which is going to get us 37.5. If we take 96 minus 37.5, we're going to get an area of the shaded region of 58.5 meters squared. And then finally, method 2, if you recognize that the shaded region is a trapezoid, we can actually use that to help us find the area. So you could treat this, I'm going to highlight it in blue, this region right here as a trapezoid, where the parallel sides are 7.5 and 12. Those are b sub 1 and b sub 2. The height of this is this length right here, which is 16 minus 10. So this height right here would be 6. So your height would be 6 for this. So you do half times 6, and then in parentheses, parallel sides 7.5 plus 12, gets you half times 6 times 19.5, also gets you 58.5 meters squared. You notice how this works a little bit easier. You could certainly treat it that way. I do want to point out that going back to these examples, you wouldn't be able to do that. Like I said, you can't, these are not semicircles. With this is a two triangles. The problem is we don't know what like this length is compared to this length. We know the whole thing is 13. We know this part, which is sort of an arbitrary part, is 6, but it doesn't really tell us what this base is or what this base is. So unfortunately, you couldn't treat it the same way in the previous questions. But this one, since you do have a trapezoid as your shaded region, you know the two bases, and you know the heights for sure, without guessing, you can do it in a second way. All right, this video is already long enough. That's the end of our guided notes. We're certainly going to see some more practice problems on this too, between the extra practice sheet, in class together, certainly giving you some independent practice to try on these things as well. Thanks for listening.